Good morning and good afternoon, depending on where you are in the world. If you're not familiar with me, my name is John Tobin. I'm from Trilio. Thanks for taking the time out of your busy day to join us. This Ask the Expert series is focused on data protection. In particular, today we'll be talking about the top 4 reasons for cloud-native data protection for Kubernetes. Our hope is to provide relevant topics and discussion around various data protection challenges in a quick 30-minute lightning talk style format. We're going to do our best to stick to the time frame today. We're going to default everyone to mute, but we want to keep it interactive. So please send your questions directly to me via the chat window. Again, my name's John Tobin. You can find me in there. It's John Tobin with Trilio in brackets after it. With that, I'd like to introduce my favorite product manager and the man I know that knows the most about Kubernetes, Prashanto Kochvara. Take it away, Prashanto.
Great, thank you, John. So as part of the series, as you mentioned, it's a bi-weekly discussion. People will be sending questions to you. I'm super excited to be here with you, John, presenting the top 4 reasons for cloud-native data protection. As part of the agenda, what we'll be doing is we'll be talking about overall market. We will be introducing the evolution of applications, talking about why legacy technologies are not able to support the cloud-native applications that are being generated today, and then talk a bit about stateless and stateful applications, and then roles and scopes within a cloud-native or a Kubernetes world. Okay, so before I start with talking about this exponential data growth problem, I'm just going to level set that I'm going to be using the terms containers and microservices interchangeably. And as part of that, all this entire conversation is going to be geared towards Kubernetes, which is the de facto management and orchestration tool for containers. Starting with exponential data growth, we've been seeing that data has been growing, at an exponential pace over the years. But in the recent times, let's say the last 4 to 5 years, the data growth has been exponential. And there is a reason for that. Containers, which are extremely lightweight because they only use the code and the pieces which are necessary to run. They remove any extraneous pieces from its DNA, which makes them extremely portable and flexible. When we say portable, we mean that these containers can be moved from one environment to another environment. And when we say flexible, we mean that the containers can scale up and down as per the demand within an organization. So what this means is that overall application delivery and development is getting streamlined. Having these small microservices makes it easier to manage and do specific tasks or work without introducing additional complexity, additional code. When we look at the market today, we see that in every realm of the world today, we see artificial intelligence and machine learning kind of terms that are being used. These use cases are exemplified or amplified very, very heavily because of containers. Because when we deal with artificial intelligence and machine learning, there is a lot of data that is being generated. And in order to learn this data easily, you need software, or you need algorithms that can be deployed in various architectures, learn from these environments quickly, and reported back into a mainline where it can be processed, analyzed, and intelligence be provided back to the user. So these use cases are being made possible more and more only with containers. And then when we look at the IT world, IoT and edge are booming, right? When we talk about IoT, it's a lot of sensor data that is coming out that needs to be collected, analyzed. And then when we talk about edge, these are smaller micro data centers, and you're trying to remove the human complexity out of it by introducing artificial intelligence and have automated ways of decision-making processes. Now, as part of this, what happens is we know that data is growing and it has to be retained. When data is growing and it's being retained, one of the biggest items that we need to follow is we need to protect it. We need to protect it and we need to analyze it so that we can be more innovative with the data that we are storing. As a result of all these different changes in the market, the application container market is growing at 30% compounded annual growth rate, which means that it's going to reach about 9 billion in 2025. So that's a very, very big number. And every aspect of the IT world is marching in that direction today. And what we've heard and seen from top IT firms and analysts, the data that they've produced in 2019 says that data protection, data security, and management are the biggest challenges in adopting a cloud native technology or in terms of managing your cloud native environment. And just to kind of give an idea as to how much data is being generated based on an analyst report by Research and Markets, over 2.5 quintillion bytes of data is generated every day just for analytic purposes. So you can just imagine, this kind of data is being generated everywhere, and it's continuously going to grow over time. Next part I want to talk about is COVID-19, the new normal. This is a topic that we are all kind of facing today. We are all well aware of what this is, and we are all facing some kind of disruption in our lives. But the kind of disruption COVID-19 is causing in the technology market is unparalleled. Businesses are going digital exponentially. The work from home concepts are growing. Companies and organizations which never really practiced working from home are forced into adopting solutions so that they can make remote workers more productive and be connected to their business without having to travel to the office and so on. When we look at the digital markets, a good example here, I would say, is there are restaurants around that we see, which were never on applications like DoorDash, Grubhub, and now all of those have been forced to do business through these kind of applications and do these kind of mediums. Similarly, every day I look at my email and I see, even my gym is now providing trainings and courses through online mediums. Education is getting more and more online. So the impact of COVID-19 is definitely going to increase the growth of data, the growth of containers. Based on a study that was done by McKinsey and Company, the adoption of digital channels by consumers across the US has been, seeing a very large spike over the past few months. Whether we look at the banking, entertainment, grocery, any kind of industry, we see that there is definitely a spike in terms of using digital channels. What analysts from McKinsey are also predicting is that this spike is going to remain even after COVID. People are adopting these technologies. They are seeing a dip in terms of on offline consumption during COVID, but even after COVID-19 in areas like China, which are much more ahead right now, they haven't seen the consumption rate, the offline consumption rates reach the same level as it was pre-COVID. And then finally, whichever industry vertical we look at, obviously the IT industry is more close to technologies. So remote working has definitely spiked up more, and we can see it has spiked up more easily in terms of adoption as well. But even in the professional business services, financial services, manufacturing services, remote working is a trend that is going up with time very aggressively. And what this overall means is that when customers are adopting these latest and greatest trends, they are going to be leveraging the technologies like Kubernetes and microservices because they are going to get them jump started much faster, and they do not want to obviously run through the same issues and challenges which were posed by traditional technologies. And as this data is growing, one of the biggest challenges is data management, data protection, and data security. And what happens if you do not protect your data properly? One of the biggest things is data breaches. Based on a study that was done by IBM in 2019, the biggest loss is the loss of reputation when a data breach occurs within an organization. Based on analytics that they've done across various incidents that have happened in the past, mostly across social media channels like Facebook, Twitter, Instagram, and stuff, every data breach incident basically causes a loss of 10 to 99 million records. And when we put that into perspective of companies that are on the stock exchanges, tech stock exchanges in the UK and the US, that translates to about a 7.2% decline, which is equal to 9 billion and 33 billion dollars respectively. In 2019 itself, there were 479 data breaches or situations where data was compromised, and that translates to about a 6.2 million loss in daily revenue. And now what we are seeing is, there are a lot of compliance and regulation guidelines that are being built around data protection and data management in general. For example, the European Union came out with GDPR, that's a General Data Protection Regulation, which imposes heavy fines on organizations that do not handle and protect their data well. And with this aggressive push towards digitalization, we are only going to see more and more of these regulations come up, because in a virtual world, you do not have you don't have like a police, or you do not have a median that is governing the overall interactions of technology. So these regulations and guidelines are definitely going to keep springing up and make the control of data tighter. A good depiction of the lost value of a company with a data breach is seen in this graphic over here. This graphic was taken from IOMart, which basically explains that looking at the company's size, it is obviously data breach is bad, but in order to solve that data breach, also it takes time. And overall, the time that they have identified is approximately 249 days. And within the 249 days, it's still a loss of company value that is occurring. So overall, definitely, data is growing. We need to protect it, not only from a security aspect, but also from an innovation aspect as well. Now let's dive into the first piece of it. Let's look at the application evolution. We know that applications have been around forever, but the overall architecture of the application has been changing gradually over time. I think the overall evolution of applications can be broken down into the following segments, right? So first, initially we had mainframes. Within the mainframe computer, applications and the data were baked completely into these systems, and was easier to track and manage these data. Then we had the server architecture, starting out with bare metal servers. With the rise of these x86 servers, applications started breaking apart large modules of applications so that they could run as independent software components. But these software components still needed to be run within the boundaries of an operating system as tightly integrated chunks. Then we had virtualization. With the advent of virtualization, the server model became more agile and nimble. You were able to take more advantage of the underlying hardware by running more virtual machines and virtual servers. However, from an application point of view, the architecture remained fairly similar, where tightly integrated components would run within the boundaries of a operating system, or in this case, a virtual machine to provide services. And then when we look at cloud native, we see that the entire application has been broken down into individual microservices, individual components. Each of these components has its own identity, has its own persona that needs to be protected. And they run independent of each other. They could have data attached to it, or they could not have data attached to it. But the overall functioning of all these microservices constitute to the behavior of an application. Now, looking over the timeline of the applications, we can see that the application DNA or the footprint has changed a lot over the years. However, the paradigm of protecting data has remained constant, but the architectures have become more and more short-lived. So as a result, we definitely need a new way of protecting these applications. Now let's talk about the legacy technology challenges. Before talking about the challenges, we need to understand the attributes of cloud native applications. So firstly, it's a new approach to building and deploying applications. Kubernetes focuses on application deployment and delivery, which basically runs containers and trying to streamline those activities. They are completely modular and microservices oriented. They also follow a service-oriented architecture, performing a task and a job, and are generally ephemeral. They're highly available. Because they are lightweight, you can spin up multiple components of the same microservice to provide high availability. They're highly scalable. We spoke about containers being lightweight, and as a result of being lightweight, you can not only scale up your containers, but also scale out your containers in the fashion that you need it. Now, obviously, in order to achieve this kind of a dynamic nature of an application or microservice, you need to develop these in newer languages and frameworks. So for example, a lot of DevOps automation tools like Ansible, Terraform are being used. Golang is being used from a more new language framework perspective as well. The other aspect is that they are highly automated and API driven. So if you think about microservices oriented architecture, you have so many different components that you want to make sure that there is automation to be able to manage it, and there is policy driven or API driven workflows that can enable you to manage your data successfully. And then obviously all these architectures or all these microservices are multi-tenant. You need to be solving the problem not only from the IT ops perspective, but from a development perspective as well. Now let's look at the characteristics of traditional data protection technologies and why they cannot match up to this new innovative technology that is out there. So firstly, it's a disparate technology, right? We are talking about cloud native applications which are built as microservices, and almost all traditional technologies are based on virtual machines. So right from the get-go, the application construct or the application architecture is different. And from a infrastructure point of view, you will need to maintain a completely separate infrastructure to manage VM-based technologies to protect cloud native applications. Traditional technologies are also focusing more on the operating system versus trying to focus more on the application itself. They take a lot of dependency of the operating system as table stakes, which is not done in a cloud native application environment. They're siloed, monolithic. They focus on the application being built into the operating system, and they are rarely changing footprint. I wouldn't say that do not change footprint ever, because even with virtual machines, you had these middleware layers and other components that could be scaled out, but you had to involve a lot of manual effort in order to do that. In a cloud native world, that happens very dynamically and in an automated fashion. And again, from a traditional data protection point of view, it's focused more around the data volumes versus capturing of the data or capturing of the application metadata and the layout topology. And again, it's built only towards IT operations mostly versus for developers. Next, I'm going to talk about stateful and stateless applications. So just by simple definition, a stateful application is one that is dependent on previous data transactions. And then when we look at stateless, a stateless application is one that does not depend upon its previous transactions to perform the next operation or execution. Initially, when containers were being launched or when containers were becoming mainstream, everyone thought that everything within a microservices architecture or a container-based world is going to be stateless. However, with the introduction of data volumes and persistent volumes, everyone realized that, hey, that is not going to be true, and it's going to be more of stateful applications. Based on analysis and research that has been done in the market, I believe it's around 70% of applications that are being run in a Kubernetes world are all stateful. And even though your application may be stateless, there is still data protection that is required for those stateless applications. And I'll dive into the details of those in my next slide. So when we, looking at the left-hand side of the screen, when we look at an application footprint, you generally have, some stateful components which talk to data and some stateless pieces which are not talking to any data that comprise the application. Now, obviously, when you are trying to back up an application or a unit of an application, you cannot back it up just by backing up these stateful pieces. You need to back it up as an entire unit, stateful and stateless. So that is one of the areas where, whether it's stateful or stateless, that you would still need to back up the entire app and back up everything that constitutes it. And then when we look at a Kubernetes system, what Kubernetes has done is there is abstraction of all the infrastructure. There's abstraction of all other layers so that everything is handled within software. So when you introduce any application, and let's say it's a stateless application, there are configuration parameters that define, okay, how does this application run within this Kubernetes space? What are the, let's say, security policies that it needs to leverage? What are the secrets or credentials that this application may need? So all that information is covered or provided in the metadata, which needs to be protected. One may argue that there are a lot of again DevOps tools that help build these stateless applications from ground up, but what we need to remember here is that microservices are dynamic. Even though you may have deployed it with one kind of automation on day one, your application footprint changes. Your application keeps changing its DNA. It keeps changing how it talks to other services, and the metadata piece may change as well. So while it's not impossible to reconstruct the stateless app as it was running, having this metadata is definitely going to speed up how fast you can bring up your application. And when we think about data protection, the two pieces that we rate data protection by are RTO and RPO. RTO is the recovery time objective. So having this metadata is going to improve your recovery time objective overall. Yeah. Finally, we'll talk about the roles and scopes in IT and how they are changing. So what has been happening is that in a IT world, we have two sides. We have the cloud infrastructure, which is focused on legacy technology, virtual machine kind of technologies. They are generally infrastructure managers, which lack visibility into the application. And from their objectives, it's more about consistency and compliance. When we look at the application development side, what is happening is that the application developers are focused more on generating or on innovating. They try to leverage the emerging technologies which may not have been vetted that successfully. They have lack of control over data protection type of operations, and what they are looking for is prioritizing productivity and speed overall. So obviously there is a challenge between what the cloud infrastructure or the operation side seek versus what the application development side seeks. And because of this, there are increasingly fragmented environments. Your data is residing in multiple clouds, multiple formats. And again, all of this exposes your data, provides more potential areas where security can be compromised or data can be compromised. We need the IT ops and application developers to work together to achieve overall efficiency in their workflows. Now, what is happening is that Kubernetes is definitely helping achieve DevOps utopia by implementing role-based access controls right from the top. So what this means is that merely having a microservices enabled data protection solution is not enough. It needs to fit into the realm of role-based access controls so that the application can provide a common communication medium that enables faster releases and product life cycles across applications. Also, when we talk about data protection engulfs data management use cases, because when we think about cloning, cloning is technically backup plus restore. So data protection also engulfs all these management of data types of use cases. And when we look at it from a backup admin's perspective, we know that, okay, the infrastructure is getting more abstracted. The focus is more from an application top-down perspective, and automation and data governance is becoming more and more paramount. From a development point of view, obviously it's an iterative process, and your data needs to be protected through all stages of your life cycle, whether it's in dev, whether it's in test, whether it's in production. You want to use data protection mechanisms, data management mechanisms to be able to successfully get these environments recreated in different clouds. And obviously you want to protect your IP not only in the development stages, but also throughout the pipeline, and then your customer data in your production stages. So obviously these roles and scopes have changed. There needs to be a unified approach to how operations and development interact with each other moving forward. So with that, I think I've completed presenting the points that I wanted to present as part of this lightning talk. Just to recap, what we discussed was, the application evolution. Legacy technologies do not, adhere or address these application evolution concepts. There is the battle of stateful versus stateless, but you need to protect both. And then obviously from a roles and scopes perspective, how IT is managing environments, how IT is approaching environments is changing. It's a paradigm shift, it's a philosophy shift, it's a principle shift. And Kubernetes is making that happen. And as a result, again, it's all data explosion and data streamlining that is going to happen in an IT world. So with that, John, I'm going to hand it over to you to see if you have any questions that we can answer.
Yeah, thanks, Prashanto. Great job. Yeah, we do have a couple of questions. I think if I could kind of distill a couple of different questions down to one common theme, I think there are a lot of companies, a lot of people out there evaluating, Kubernetes, whatever flavor, as a platform going forward. And I think they're wondering, where are the people that we're talking to in their journey? Like where are they when they're considering data protection for container workloads like we're talking about today?
I would say that looking at the timeline, initially when customers started, leveraging containers, they were using it more for stateful workloads. But as I mentioned, stateless workloads, and as I mentioned, stateful workloads are now the main theme around containers as well, because of which we are seeing, the data protection challenges come up more and more. Where customers are, I would say that I will break the answer in terms of verticals. So obviously, if you look at IT verticals or manufacturing verticals or finance, banking kind of verticals, those are really ahead in terms of container adoption. And then, the education, health services industries are also picking up aggressively. and all the other industries, transportation and things like that, they are also, because of things like COVID, are really aggressively marching towards the container journey as well. So I would say, so there are different stages based on different verticals where customers are, but the overall push towards cloud native or Kubernetes is at a high level, really, really aggressive.
Yeah, that's a good question, um, or good answer, I should say, and a good question. I think the only other question that we have right now is how can people that are looking, at data protection for Kubernetes, they have some decisions to make. How can we help them? Like, how can they evaluate Trilio?
So I would say that there are different mediums that we are providing Trilio solution that people can evaluate. There are a lot of demos and videos that are available on our website that people can take a look at to see how we are addressing this cloud native problem. There are also live labs that people can access directly through our website and play around with the product with it, even without installing it in their own environment. And then finally, we have a freemium model where people could, leverage the product, try it out in their own environment, and see if it solves their needs. So this is actually a good segue into one of the future conversations that we'll have around, top attributes of data protection, and we'll be discussing more around that on those calls. But for people who are interested or who are facing these challenges and the problems that we are talking about in this call, I would highly recommend them to take a look at our website and see what we have been working on, and provide feedback if they have ideas and suggestions as well.
Yeah,
Okay.
good point.
So I assume that was the last question, John. And if there's nothing else, I would like to thank everyone for joining today. I'm Prashant Kochevara. If you have any other questions and comments for me, you can reach out to me via my email, which is in front of your screen. And also want to point you to the ebook that we are preparing as part of this, which is the kind of the extended version of this talk track, going over the top 4 reasons why you need data protection for Kubernetes. It will provide more additional details, colors, and everything you need to know as to why data protection is important for a cloud native or a Kubernetes